Okay, in this video we're going to start talking about the graph of a function. So what we mean by the graph of a function f is the collection of ordered pairs x, f of x such that x is in the domain of f. Here the basic rule of thumb is that we're treating our y-coordinate as the output f of x. So for example, f of x equals x squared really has the graph y equal x squared. Picking points, if you pick points, you'll see that that is -2, if we make a little table, -2, -1, 0, 1, and 2. As our y values, we have -2 plugged in is 4, -1 is 1, 0 plugged in is 0, 1 is 1, 2 is 4. So in other words, we have the ordered pairs -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Hopefully that makes sense by now, given all the graphing we've already done. Connect the points. Okay, so you get a parabola. Now, function graphs are actually very helpful for discovering lots of information about a function. This is information that can be hard a lot of times to find from a formula. For example, we saw on the last page that f of x equals x squared looks like this. It's the parabola, right? But in its domain, we already know is all real numbers. However, there's another way to see the domain. The other way to see the domain is what are all the domain is the all x values, right? All x values used. Okay? Well, it's all the x values used. Namely, it's going to be everything down here. In fact, it's actually going to be all real numbers because we see eventually we would actually get all of the x values if we went out far enough, because slowly we can keep putting those in and we just get higher and higher values in y. However, the range is all of the output values. That is, the range here is equal to all the y values. All y values we get back. In other words, all the y values we get back out of this, we can see is everything from 0 to infinity. Or if you prefer, or x greater than or equal to 0 if you prefer. Doesn't really matter to me. But what that tells me is this is actually really nice for this, right? Here it's not entirely clear unless you start thinking, oh, well, actually x squared. I know if I plug 0 in, that's the lowest I can go, and I could always get any positive number. But that's really hard to kind of sort through and think about, whereas this is much more obvious. So let's do an example to dive into this a bit further. Let's use the graph of the function f shown to the left to find the domain of f. The function values f of -1 and f of 2, and let's find the range as well. Okay, well, if we look over here, we see that the domain, again, is all of the x values that get used up. Well, we see here, we start using x values over here, and we keep going, and we get really, really close to using this x value, but never quite reach it. So we'll put a dotted line there. So that should be my domain. Namely, the domain should be x, the domain should be just either, if you prefer interval notation, which I like interval notation, I know a lot of students don't, but I do, be -1 including -1 up to 5, but not including 5. Or if you prefer, you can use you can use -1, x is greater than or equal to -1, but less than 5. All right. Well, what about for the function values? Well, for b, we see that f of -1 corresponds to what? Well, we're asking here, what is the y-coordinate when x is -1? What y-coordinate do we get back? Well, here, if we go over here to x equal -1, we get the y-coordinate back 1. Whereas with f of 2, we're asking if we go over to x equal 2, what y coordinate will we get back? Well, we get negative 3. Side note, an important thing to note here, which makes sense for the domain, if we tried to do f of 5, we would have that the function is undefined. Why? Well, because when we try to get at 5, when we try to get a y value back, we can't get there because there's a hole. Okay, we never quite reached that point. All right, finally, for C, what values are hit? Well, here we see the lowest y value is down here, but the highest y value is up here at 3. So that should be my range. Namely, for C, my range should be in interval notation, that's negative 3, including negative 3, all the way up to positive 3, including it. Or, if you don't like interval notation, y is between negative 3 and 3. So this is actually something really nice about graphs, is that it's really easy to see the range from them. Now let's have you try an example. So go ahead and use the graph provided for the function f to find the domain of f, the function values f of 0 and f of 3, and the range of f. And on the count of 3, I'll reveal the solutions. 1, 2, 3. So here we see that the domain, because we actually would eventually hit all real numbers except negative 3, because there's a hole there, we see that x not equal to negative 3, or if you like interval notation, be negative infinity up to negative 3 union negative 3 to infinity. For B, the function values f of 0 and f of 3 are just found from the ordered pairs. Namely, when x is 0, we look and find where's our y value. Well, our y value is 3. When x is 3, we have that our y value is negative 6. Range. For range, we have that no matter what value, our y values all go at highest of 3 and all the way down. Here we miss the hole because we do get a y value here, right? So it's y less than or equal to 3, or if you prefer, negative infinity up to 3, including 3. Even more important as far as graphs of functions, we can even tell whether a graph actually represents a function using the vertical line test. Namely, a set of points in a coordinate plane is the graph of, and this is important to know, it's the graph of y as a function of x if and only if no vertical line intersects the graph at more than one point. Here, it's important to realize the vertical line test only tests whether y is a function of x. It isn't totally clear why this matters right now, but if you were to pursue math in the future in terms of most notably pre-calculus, it really matters. So let's do an example. Which of the following of these graphs represents y as a function of x? Well, we can use the vertical line test. Namely, if we were to draw any vertical line through these, in order to be a function, we need to intersect the graph in only one spot. Here we see this one fails the vertical line test because I can draw a vertical line there and it hits it twice. So not a function. But here, no matter where I try to draw a vertical line, it doesn't matter. I'm never going to be able to intersect the function in more than one place. So this is a function. Here, if I try to draw vertical lines, I have a similar thing. It's okay to not hit the function. That just means that's not part of the domain. But where I do hit the function, I see that it only hits it one time, and so it is a function. And now let's have you try an example. So use the vertical line test to determine whether the graph represents y as a function of x. On the count of 3, I'll reveal whether it is or isn't a function. 1, 2, 3. And the answer is it is a function because no matter where you try to draw a vertical line, it will only intersect it in one spot. If you would like some more practice in working with the brief graphical understanding of functions we've talked about, be sure to see page 56 of the textbook and work problems 1 and 7 through 14. In our next video, we'll be talking about zeros of functions once again.